Okay, so we're Team Tree, and this is our carbon capture public park proposal.
Hello, my name is Angelina Buhay, and I'm the research manager. I'm in charge of the overall research development and documentation of this project.
Hi, I'm May Bubbles Thomas. I'm the project coordinator and creative design lead, and I'm in charge of coordinating when we work, when our schedules, and I also am in charge of the design of our presentation and the overall look of our model.
Hi, I'm Iris Nicholson. I'm the project manager, and I'm in charge of some overall planning and basically the overall execution of the project. I contacted experts on behalf of the team and helped with everything. So we're a group of 10th graders at the Amateur School for Young Women Leaders. And like I said earlier, our team is called Team Tree, and we've been looking into different ways to reduce the amount of carbon in the atmosphere. So I've been working on carbon capture, on this carbon capture project idea for a couple years now. And I was originally working on the idea of a carbon capture compound. I had researched many different carbon technologies across the world and thought it would be incredibly beneficial if they could all work together in one location that could ideally be replicated in different cities across the globe. As we began to repurpose the original project for this competition, May suggested a carbon capture park.
Yes, we wanted to create a safe place where people can come with their families to play, relax, have fun, and exercise. But also another important step of climate change is getting people to be on board with it. And by doing this, we wanted to try educating people about technologies that we could use or what they could do to contribute to this. And this is by implementing our carbon technology into the park.
Our solution to this problem is to create a public park with carbon capture incorporated into the system. So now we'd like to discuss our purpose. Our purpose is to reduce the levels of carbon dioxide present in the atmosphere in hopes of reducing climate change, as well as improving air quality within cities. In addition to educating people about the effects of climate change and possible solutions that exist, we believe that it's important to educate the public on the dangerous effects of climate change and the benefits of renewable energy and different climate-friendly technologies. Through teaching the public, we hope to engage the public in an effort to stop climate change. Not only will this public park be designed to remove carbon dioxide from the atmosphere and prevent the worst effects of climate change, but it will engage others in the prevention and mitigation of climate change. So with our engineering method to create this project, we started with research, of course. We began with researching what climate change is, the effects of climate change, and what we can do to stop it. So on our research, we found several carbon capture technologies that we wanted to implement into our park, including biocapture, Carbfix, and a mechanical tree that was designed by Arizona State University to prevent climate change and absorb carbon dioxide in the process of being a sort of mechanical tree. And we settled on the idea of implementing all of these Carbfix, BioFix technologies into our park, and wanted to create an idea of a climate park, which is a park that incorporates all these carbon capture technologies into it. We brainstormed on different aspects to include in the park, and we finalized, the different aspects after consulting with experts. We sent out a survey on park aspects we could include, and the survey simply contained questions about, what people find important about a park, what they'd like to see in a park, if safety matters to them, if, public engagement matters to them, what could engage them in climate change. And our results were overwhelmingly for, including carbon capture technologies. That is what our survey results said, and that's what, people were interested in. So we developed a prototype that basically depicts this park, and even though it won't be the exact model, we'd like to have a park that incorporates these carbon capture technologies in it. And we wrote up a proposal as well.
Okay, so now I'm going to talk a little bit about our research and contacting different experts. So as Angelina said earlier, some of the carbon technologies that we researched were Carbfix, BioUrban, ClimeWorks, the mechanical tree, tree pods, and ironstone, all of which we'll go into a little more detail on later in the presentation. So we reached out to many experts in the carbon field, such as Dr. Sandra Osk-Schinbrüster with Carbfix and Juan Wurzbacher and Miss Franziska Kleinbrewer with ClimeWorks. We also reached out to Dr. David Stone with Iron Shell, and we reached out to the BioMetech team. And so we're about to get in depth about all of what I just summarized for you. So we're going to start with Carbfix. So Carbfix is a technology from Iceland. We reached out to Dr. Sandra Osk Brewster, who is the head of CO2 mineral storage at Carbfix. We asked her a few questions about the technology and the Carbfix process, and here's a summary of what we learned. The CO2 is captured via a direct carbon capture system, which we will go into other types later in the presentation. And after it is captured, it is brought to a lab where it is dissolved into water, creating carbonated water. The carbonated water is then injected into basalt rock, which is the most common rock in the world. Once injected, it reacts with the rock to create new minerals in the rock's pores. Within a few years, the carbon dioxide has solidified into the pores of the rock and created a solid rock. This process is naturally occurring in nature and does not negatively impact the environment around it. Carbfix just accelerates the naturally occurring process. In Iceland, Carbfix is powered solely on renewable energy, which we hope to be able to do at our park. While roughly 25 tons of water are needed to dissolve a ton of CO2, the water can be recycled and reused. And we asked about the general safety of the project. I was assured that if a pipe containing carbon dioxide burst, all the CO2 would return to the atmosphere without harming anyone. And in case a water pipe bursts, there are procedures in place to stop flooding. When talking with Dr. Osk Schenbrewster, we learned some more about the future of Carbfix. They're currently looking into starting a Carbfix process in Minnesota and looking into opening a US-based office. She continued to say that they would be interested in potentially working with a project such as ours, and they're also about to start a pilot experiment with using seawater to inject into the rock. After all of this, we concluded that Carbfix would be a significant addition to our park as it takes carbon out of the atmosphere permanently.
While Carbfix does a spectacular job at permanently storing carbon dioxide, we will still need to somehow manage to capture it in order for it to work. One way to capture CO2 is through direct air capture. ClimeWorks is a direct air capture system, and so we reached out to Dr. Jan Wurzbacher, the co-founder of ClimeWorks, along with Miss Franziska Kleinbrewer, the marketing and communications head at ClimeWorks, with some questions about their technology. ClimeWorks is essentially a bunch of fans which draw air into them, and once that air is inside this fan, there's a filter which carbon dioxide is chemically bound to. So any carbon in the air gets stuck to the filter while the rest of the air continues through the fan and back into the atmosphere. After the filter is full with carbon, the container is heated up and the carbon is released from the filter and collected. Our plan involves transporting the carbon via pipelines from the ClimeWorks machine to our Carbfix. From our ClimeWorks interview, we learned that in Switzerland, ClimeWorks is powered solely on renewable energy. Because it uses a fan, ClimeWorks does not need any air to draw CO2 into it. And it's well adapted to weather conditions such as rain. It is also a scalable project, so it's flexible, as in we can make it smaller or bigger depending on the space that we have. Our plan to incorporate ClimeWorks into the park involves it keeping it slightly away from the public and surrounding it by a small fence for public safety. The carbon it captures would be transported to the Carbfix facility and put directly into the ground. Based on our research and talking with the ClimeWorks team, we decided ClimeWorks would be an excellent addition to our park.
The BioUrban artificial tree is another option that we've chosen. And the BioUrban artificial tree sucks up as much air pollution as 368 real trees. In other words, the BioUrban artificial tree sucks up as much as a tree sucks up in a year in one day. It is a metallic structure which is about 10 feet wide and 14 feet high. The machine captures carbon dioxide in the air, and through using microalgae, it carries out a much faster photosynthesis process to produce oxygen. Just one of these BioUrban trees has the ability to produce enough oxygen for 2,850 people every day. We reached out to the biotech team and unfortunately never received a reply. However, through our own research, we decided that BioUrban trees would have a positive impact on our park due to the fact that the technology turns CO2 into breathable oxygen. Our BioUrban trees also improve air quality in places where they are located. Also, another technology that we're working on and that we've researched are mechanical trees. Mechanical trees are designed by Arizona State University, and each column or tree contains a stack of absorbent-filled discs, which when the column extends, the discs spread apart and air flows through them, and CO2 is bound to the discs. Then the discs are lowered into the container where the CO2 is released. The column extends up again to capture more carbon dioxide after taking that carbon dioxide in and capturing it. The system relies on one to capture the carbon dioxide. Each cluster of 12 trees would remove 1 ton of carbon dioxide per day at the cost of $100 per ton, which is relatively cheap. We like the idea of using mechanical trees in our park because people can walk among them and see carbon capture technology at work. These trees would help capture CO2, but at the same time, they would educate and engage the public on carbon capture systems and how to prevent climate change.
Okay, so another mechanical tree option that we researched was tree pods. The tree pods are designed by Klaus Lackner, who also worked in designing the mechanical trees. They run off solar and kinetic energy. They take in carbon dioxide in almost 1,000 times faster than normal trees and can hold 90 tons of carbon dioxide at any time. His original design would be powered by solar panels and hammocks and seesaws nearby. The trees also have a lighting system so people can see at night and hang out under them. These trees form groups, which can then be used to form a canopy of tree pods. The canopies provide shades for pedestrians. Tree pods are made from recycled materials and capture carbon using a friendly, non-harmful chemical compound and then release it into water to be stored. These trees are used in different parks around Boston to help capture carbon dioxide. And incorporating them into our park would provide places for people to hang out and play, as well as be engaged in helping combat climate change by capturing carbon. Pedestrians would play an active role in capturing carbon as they would create the kinetic energy which would be used to power the tree.
Ferrock, designed by Dr. David Stone Ferrock, it is used as an alternative to cement. However, unlike most cements, Ferrock is carbon neutral. We emailed Dr. Stone and here's what we learned. It is created from a mixture of steel dust and silica. It is mixed with ferrous rock and water and then exposed to carbon dioxide. This mixture hardens as a result of a chemical reaction similar to rusting. As the iron in the steel dust absorbs carbon dioxide, iron carbonate is formed and the material continues to harden. The resulting product is strong and carbon neutral. We are looking into using sustainable building materials for the facility at our park because it represents what this park stands for. Each of the companies have done extensive testing, and we are fairly confident in their technologies and how they would work with our park. However, we did reach out to the public to see what was important to them when building a park. The general consensus was that everyone believed it was important to educate the public on climate change. They were interested in learning about the environment and what is being done to help it through seeing technologies, research, and projects happening. On top of this, a lot of people were interested in visiting somewhere that shows these technologies and that are engaging. And 100% of these people we asked believed that a carbon capture park was a good idea.
So now we'd like to discuss our prototypes. We have a mechanical tree, and this mechanical tree represents the Arizona State mechanical tree that we discussed earlier. So we have a prototype of this mechanical tree, and these laser-cutted wood models represent the wooden disc or the disc that absorb the carbon dioxide, and the mechanical tree basically retracts and expands based on the carbon dioxide in the system. So the mechanical tree is the main technology that'll be improving, the public opinion on climate change, or, the effort to stop climate change and engaging people in this effort, because it is visual. You can see it. You can see a mechanical tree, and you can see what it does when it retracts and it expands to take in carbon dioxide. So this is important because it absorbs a lot of carbon dioxide, but it is also important because it shows the public that we can do it.
Yes, and then on top of that, on top of that, we have another tree model. It's a little hard to see because it's stuck on our prototype, but it's our BioUrban design. And it's basically a tree that uses algae, and algae feeds on carbon. And it's a completely sustainable and safe way to take carbon out of the air. And on top of this, we have, it's a little hard to see, we have a community garden. So we were planning
here, right there.
Yeah, so we were planning on having, because algae grows quite rapidly when it's being fed.
Oh,
When it grows quite rapidly when it's being fed a lot. So a nice fertilizer that farmers use is red and brown algae. And while this isn't a farm, we thought excess algae that's being grown rapidly because of the amount of carbon it's getting could be used as kind of like a fertilizer. And it's also another engaging way we put into the farm.
Okay, so I'm gonna go back and share this. Okay, and so here's some more photos of the prototype.
Yes.
You can see lots of different playgrounds, trees around, different carbon technologies and public restrooms and recycling bins, all sorts of stuff you would expect to see at a regular park, and then extra stuff you would see at a carbon capture park.
And on top of this, we'd also like to add that this entire plan can be implemented into anywhere that can take Carbfix. We don't even need Carbfix to necessarily be in it. This is just an example of what it could look like.
Because bisalt rock is the most popular, most common rock in the world, there's tons of it all over America and all over lots of different countries. So it'd be a pretty easy place to find a location that would have the rock you need. So what are our hopes for the future? How do we plan to move forward with our design? So we hope to find a city to partner with to help fund the building and farther design of our park. We would start with the previous technologies mentioned in these slides: Carbfix, ClimeWorks, BioUrban, mechanical trees, tree pods, and Fair. But hopefully would be able to incorporate new and emerging carbon technology as it is farther developed. We hope to have lots of displays and activities that help educate the public on carbon capture technology. We hope the park becomes a community-loved place and encourages people to make more eco-friendly decisions and get farther involved in helping reverse climate change. We want to help teach young kids how incredibly important our world is and what we need to do to help save it.
So why really is this important? We know that climate change is having extreme effects around the world today, and that especially low-income countries are affected significantly by this issue. We know that the waste that is produced by the emission of carbon dioxide causes global warming and causes horrible effects around the world. And even though we are still seeing the effects of climate change today, and we will continue to see the effects of climate change in the future, we want to prevent it as much as possible. To prevent the worst warming, we need to practice carbon capture technologies, as carbon capture is very important to every aspect of preventing climate change and mitigating climate change. This park is a system that would introduce the idea of incorporating removal of carbon dioxide into our societies and including the idea of working towards solutions to climate change in every aspect of our lives. This park would give the public interest into the effort to stop climate change, and it would also be an important effort to stop climate change itself. It does both stopping climate change, but also showing people that it is an important issue that we need to work towards stopping today, not tomorrow, not in 2050, but today. And that's why this is a very important project.
Okay, so we have a link to our sources and further research here, and we've included it in our formal report. And then does anyone have any questions?